Are you tired of analyzing your data through non-visual means? Well, we have the solution for you. Introducing Orange, a new and fruitful and fun data mining software made available on the internet. So what is Orange? Orange is a component-based visual programming software for data mining, machine learning, and data analysis. Workflows within the canvas are created by linking predefined or user-designed components called widgets. So why do we use Orange? Firstly, there is no need for programming at all. Everything is done visually. There's also a multitude of machine learning algorithms made available within the software. It also allows for classification and clustering for data analysis. And most importantly, it is free. So what is classification? This is basically the process of organizing data into categories or class labels for its most effective and efficient use. How does it do it? Well, it learns from past data and recognizes the relationship between the attributes and the labels. So how do you go about getting Orange? Simply type in the link below and will lead you to the download page. When you're on the page, click Download Orange and install it, and you're good to go. Once downloaded, go to Applications and look for Orange.
So first we'll be training the available data files in order to predict future unknown instances. So open a new data file and title it test. Alright, so now you drag a file widget over and then you double click it in order to open your data file. And then for this example, we'll be using the vehicles data file. So for the vehicle files, it's actually a numerical data set, and then afterwards, later in the tutorial, we'll be going through analysis of categorical data sets. So now you would like to look at the data files inside this folder, so we'll open up a data table and double click the data table to look at the values and attributes. So for this data file, there are a total of 846 examples and 18 attributes. So before we start with training our dataset, we first have to check if the dataset contains any outlier that may affect the machine learning accuracy. So to do so, we have to visualize the data. So go over and select either a scatter plot or a linear projection. For this tutorial, we'll go through the linear projection. Double click on linear projection and then you notice that there are a few outliers that are further away from the other data sets, and these are the outliers that we wish to remove. So you close it, output the file to the outlier widget, and you double click on it. So now you have a choice to what? Okay, from here you can select the Euclidean distances you wish to use to identify the outliers. So for this tutorial, you'll select 3 and then you'll output your outliers to the linear projections. And notice you output the outliers and you open up and you notice that these these bold data files are actually the files that are identified as outliers. So we need to remove all of them before we can proceed with our visualization. We have to remove all of them before we can proceed with our machine learning. So from here onwards, you would like to only export the inliers and not the outliers into your new data file. So from here, you just output it to classification tree, for example, and you can see the outliers is actually being output from the outliers widget into a classification tree. But we like to use the inliers and not the outliers, so you double click and then connect the inliers to the data file and click OK. So now only the inliers data will be used for classification.
Okay, now looking at categorical data, we'll be using zoo as an example. So same thing, double click, file. Under the tab, go to browse documentation datasets. Scroll to the bottom and you will find zoo. So as you can see from here, zoo has 101 data instances, 16 features. So now it's loaded. Now in order to classify the data, we have to look at we have to use our learners, and that will bring us to the classify tab. Open it at classify and you'll get a list of learners that you can apply to the file zoo. So right now we do not know which learning algorithm is best for the file data. So for this tutorial we'll open 6 algorithms for the assessment. So we'll use naive Bayes, neural network, classification tree, CN2, random forest, and k nearest neighbor. So now simply connect file to these learners. Now that we've connected it to all the learners, go to test learner. Test learner can be found under the evaluate tab. Now we connect the learners to test learners. This will help us determine which learner is most suitable for this set of data and which is more likely to lead to a more accurate prediction. So right now if you click on test learner, it doesn't show anything here. That's because you need to connect your data file to your test learner as well. So now that it's loaded, we open up and we can see over here this table. What we need to focus on here is CA. It means classification accuracy. Now if you look on the left, you'll see some sampling options. The assessment for the classifier models are different depending on the estimation methods you choose. So random sampling over here, which is where we are at now, gives a classification accuracy of approximately 91%. Cross-validation will give an accuracy of about 94%, but it's usually used for a much larger data set. And leave one out takes a longer time to process the data, but it gives you a more accurate reading, as it chooses only one data instance for testing and the rest for training, and then repeats the process until all the single instances are used for testing at least one. It is only recommended for a small data set, as it is very time consuming for a large data set. So to determine which one to use, you have to select the estimation method that's best for your set of results. So in this sample, as you can see, under classification accuracy,
As you can see here, k nearest neighbor has the closest value to 1. Now orange follows the two-step methodologies in classification. However, in orange you do not have to separate them. You do not need separate testings for orange. In fact, over here, uh, at the scale over here, you can choose how many percentage of your data would be a training set and how many percent of it would be test set. So right now, let's bring it to 66%. So this means that 66% of my data would be in the training set. And as you can see, the number changes. Let's let the program run. Okay, now that we have set our sample set at 66%, now test at 34%, let's look at our classification accuracy again. Once more, k nearest neighbor has the highest accuracy as it is closest to 1. And if you want to double check against other classes, over here we are looking at the accuracy in terms of mammal. If we want to look at, for example, amphibians, the number changes again. But once more, k nearest neighbor is the highest, has the highest classification accuracy. So what we can do is now we can be sure to use k nearest neighbor for the prediction that our test learners. We can also bring out our confusion matrix. Now connect test learners to confusion matrix. Now the confusion matrix allows you to see how the classifier classifies the data and which data is classified correctly and which is not. So on the left here you can look at the different learners that we have, and if you click on correct, it will highlight the amount of classes that it has predicted correctly. So we can run through it. And as we can see, k nearest neighbor still has the most amount of correct predictions, and this corresponds with what the test learner has previously shown, which is the highest level of classification accuracy.
Orange also allows you to view the model's prediction on data, and we are doing it from scratch. So how do you delete the data is you drag this across, right click, and click remove all. We are also going to use the same zoo file, so double click, reload, and you see it's over here. Drag it out, and you can type this thing called data sampler. When you click on the data sampler, there are options to select stratified sampling and random sampling for the current pool of existing data that you have. Whenever we do a prediction, we will need to connect them to the naive Bayes and classification tree to the predictions by dragging them across. Click OK. You see a pop-up window when you drag the connection from the data sampler to the prediction. Click Clear All and choose the remaining data and drag it across to the data. Sometimes you might miss the green arrow because you have to be very focused on the center of the box. So you have to ensure that it's connected to the center of the box. The model is also able to show you how you can predict the type class of the various attributes. So you can use a nomogram for that. Double-click on the nomogram and you can see the type of target class over here by clicking on a drop-down list. So let's say if you want to see if the data input is a bird, you can drag these points across by sliding across the data. 1 means yes and 0 means no. So it will show you the probability over here. As for predictions, you can double click. As for predictions, you need to drag the naive Bayes and the classification tree to the predictions. Do not forget to connect these three data sets to the predictions. Double click on the predictions and you'll be able to see how they come up with their answers. So for example, they are able to tell the bear is a mammal because they are looking at 16 of the data attributes. And you can look at how they are seeing these data attributes by seeing this input from hair, feathers, eggs, milk, so on and so forth.
Okay, so now I'm going to show you the different ways that we can use to visualize data. So on the left hand side of the screen, you can scroll down and you can see the visualize tab. So you click on the tab and you can see several widgets that you can use to visualize data. So due to time constraints, we will only focus on 4 of them. So distributions, attribute statistics, scatter plot, and linear projection. So first we have distribution. So click on the widget and you appear here and you connect it to the file. Yep. So using the same zoo sample file, we double click on the distribution and you can see this graph coming up. So here we can select the variables that we want to see. So for example, hair, and the displayed outcomes, all the different types of zoo animals. So the x-axis would be hair and the y-axis is the frequency. So over here we have the probability plot. So let's say our target value is amphibian. So that means that amphibians have 0, no hair, and there is a low number of amphibians in the sample file. Yep. So we can select other variables according to what you want to see as well. Yep. You can also click Save Graph and save the image for further usage. So next, we also have the attribute statistics visualization widget. So similarly, we connect the file to the widget, double click, and here we can see some attributes on the left-hand corner, and category and total values. So for categories, we have 0 and 1. In this case, these nominal values are assigned numbers 0 and 1. 0 here means no and 1 means yes. So this means that 57.4% of the dataset has no hair and 42.6% of the dataset has no hair. So accordingly, you can click on the different attributes to find out the different percentages for the different attributes. Yep. You can also save the graph if you want to keep it for further use. So now we'll look at scatter plot. So connect the file to the scatter plot, double click, and here we can choose the x and the y-axis attributes according to the variables. So here, let's say we choose hair for the x-axis and feathers for the y-axis. Yep. So you can see the data sets here distributed on the scatter plot. So for the point color, we can choose type. So red would be amphibian, red would be bird, green would be fish, and so on. So to see where the anomalies are, you can also zoom into the scatter plot graph. So create a box and you can see the different points. Yeah. So for example, this orange is an insect. So this insect has hair but no feathers. And you can see the majority of the data is actually mammals. So for the additional point properties, this can be used for complicated sets of data with many independent variables. So if you want to narrow down very precisely your data, you can select point labels, point shapes, and point sizes accordingly. Okay, so finally, we go to linear projection. So connect the file to linear projection, double click. You can move all the attributes that you do not want to appear on the graph down to the hidden attributes. And yep, you see the axis, feathers, hair, milk, and eggs. So over here, you have the types or classes of the different zoo animals. So you can see accordingly. So birds will have feathers and they lay eggs. So you can also zoom into the graph like what you did before to see the different data points in close-up form. Okay, so now when we use it in predictive analytics, we have to first select attributes. Go to select attributes and link select attributes to the prediction widget. So here we can see available attributes, class, and meta attributes. So we'll move the two meta attributes here and then move it to the attribute set and click apply. Okay. And at the predictions, let's say we want to see the amphibian prediction possibilities. So double check again. Okay, so now it's amphibian. Okay, so you click apply. And we can use any form of visualization to see our prediction. So for example here, we will use the scatter plot as an example. So link it to the scatter plot and you can select your x-axis attributes and your y-axis attributes. So let's say hair and feathers and we have the point color type. So you have all the attributes here and you can zoom in to see. So for example, we zoom in on this part. Yep. So we can see the attributes. So for example, for this data point, naive Bayes classified it as an insect while classification tree classified it as a mammal. This data point is actually an insect. So this means that the naive Bayes prediction model is more accurate than the classification tree model. We can also use the other visualization widgets here to show our final prediction as well.
And there you have it, a 20-minute tutorial on classification in Orange. From testing the dataset, to predicting the categories and class labels, to finally visualizing your final results. I hope you've learned a thing or two about classification in Orange. Until next time, thank you.